Hello students, so here's an example where you can solve quadratic equations by grouping when your leading coefficient is not a 1. So if you notice this leading coefficient is a 9, right? So I'm going to show you the method I called factor by grouping, right? Or factoring groups. So notice here you have a 3-term polynomial. Well, our job here is to split it into 4 terms, right? So we do 9x squared. What we do is we want to split the middle term, 12x, into 2 things. We keep the first and the last term the same, okay? So we're going to have to do some side work. We go to the side and we say, okay, how do I split 12x into 2 things, right? It could be 8x plus 4x. It could be 10x plus 2x. It could be anything, right? There's so many possibilities. So I don't know if I just sit there and do trial and error. It'll take me forever. So there's actually a way to do that. What we do is we multiply first the 9x squared and the 4. So we do 9x squared times 4 on the side. And 9 times 4 is 36. So we get 36x squared, right? Well, and then we ask ourselves a question. We said, okay, I need to come up with two numbers that multiply to give me 36x squared. And will also add to give me 12, okay? For the sake of time, this might take you a little bit of time to play with the numbers, right? But if you are familiar with this method, it shouldn't take you that long, right? So 2 numbers to multiply to give you 36 and add to give you 12. Well, right off the bat, I think it's 6 and 6, right? So if I take 6x and I multiply by 6x, I get 36x squared. And if I take 6x and I add to 6x, I get 12x. So I know how to split my 12x now. I'm going to split into a 6x plus a 6x. So I put those things in here, 6x plus 6x. Right? Now I have 4 terms, which means I have 2 groups. So I can split this first group up, and then there's a second group. And I'm going to factor the GCF in each of these groups. So look at the first group. You have an x in common. Now there's also a common things in 6 and the 9, right? So you can factor out a 3 out of both of them, right? You can factor out a 3. That means they are both divisible by 3, right? So 9 divided by 3 will give you 3. X squared divided by x will give you x plus 6 divided by 3 will give you 2. X divided by x give you 1, so there's no x left, right? So 3x plus 2 is what we call the leftover. Bring your plus sign down, and then look at your second group. The 6 and the 4 have a number in common. It is a 2, because the 2 is divisible by both 6 and 4, right? 2 goes into 6 3 times, and then there's an x left. Plus sign, 2 go into 4 2 times. And all of that is equal to 0. Okay, I'm going to draw a line here just so that you guys don't get confused. All of this over here on the side is called side work, right? I do that on the side so that I know how to split up my middle term. All right, now, every time you factor, if you do it correctly, you should see a common factor here. If the problem is factorable, by the way. So our common factor is 3x plus 2. That becomes its own factor. And then the other factor is the leftover, right? Where the leftover for this one is 3x plus 2. Oh, so they happen to be the same. 3x plus 2. So according to the zero product property, if you have 2 things multiplied to give you 0, then each of them must be 0, right? So 3x plus 2 equals 0. And this one could also be 0. Because they are the same equation, I only have to solve it one time, right? So 3x equals negative 2. Move the 2 to the other side. And then divide it by 3 to give me negative 2 over 3. Okay, so I have one answer, one solution. But it comes out of 2 expressions. So again, I think I mentioned this before to you guys. But let me remind you, whenever this happens, you have 2 exact answer twice. It's called double root. Okay, double root. This means your graph touches the x-intercept at only one point, which happens to be the vertex.